Okay, let's do problem 2. It's a related rates question. So here's the statement of the problem. It says, a paper cup has the shape of a cone. Let me draw a little cone here. And we know some things about this cone. This cone is going to have a height of 10 centimeters. So here's the height of the cone is 10. And it says the radius is 3 centimeters at the top. So this is 3. Alright, if water is poured into the cup at a rate of 2 cubic centimeters a second, how fast is the water level rising when the water is 5 centimeters deep? So this is a related rates question. So we have several things here that we want to relate to each other. We're told how the volume is changing, and we're going to figure out how the height is changing. Alright, so we can make, if we have, what is it going to look like? Okay, so we see the picture of the cup on the left, and now just at some moment in time, what is it going to look like? It's going to have some height, and it's going to have some radius. Okay, so that's the water level that I just drew. So this little strip here is supposed to be where the water is at a certain instant. Alright, and so we have the formula from the last problem for the volume of a cone is pi r squared h over 3. Okay, so look, we have the rate at which the volume is changing is giving us dv dt, right? And what we're looking for is how fast the water level is rising, which is dh dt. So we're going to take this equation that I just wrote down and take the derivative of both sides with respect to time, and then we're just going to solve for dh dt. So to make things a little bit simpler, I'm going to get rid of this r. Okay, so it turns out that once they tell us what these measurements are, we know that the radius is 3 and the height is 10. Okay, and when they put that kind of constraint on the cone that they're talking about, we can figure out what the radius is in terms of the height, and then we'll just have v equals some function of h, and that will make all this easier. Okay, so let's do that. So the way to do it, or the easiest way to do it, is just to use similar triangles. So what I'm going to draw now is a cross section of this picture. We have, oh man, I'm going to turn on this thing that makes my hand more steady. So we have one side of a triangle, another side of a triangle, and the hypotenuse of the triangle. So that thing that I just drew is supposed to be this triangle. Alright, so we've got r on top, and we have, oh, I'm sorry. Okay, so forget about what I just said. I made a mistake. So this triangle that I just drew, that I'm redrawing now in green, is supposed to be this big triangle. Okay, so this is what I'm gonna make that thing on the right the big triangle. Okay, so here's the big triangle, and inside the big triangle I'm going to write this smaller triangle. So this is just a cross section of that other picture. So in that other picture we know that this side is r and this amount is h, right? Okay, so we're going to use the similar triangles trick like we used in class to find h, or what do we want? We want r in terms of h, right? Okay, so this side, the big side, is 10 because they tell us that 10 is the height of the cup. So the whole length of the big triangle is 10, and this top part is 3 because they tell us that the top part of the big triangle is 3 right here when they tell us the radius of the cup. So by similar triangles, similar triangles means that the pink triangle and the green triangle are just the same triangle at different scales. So that means that the relationship that 3 has with 10 is the same as the relationship that r has with h. Okay, and this is great because now I can solve for r, and then in my main equation I can just have one variable h. So let me do that. So this is very easy, right? I just multiply both sides by h. So r is equal to 3 over 10 times h. Okay. And I'm going to use that now to write volume as just a function of one thing, which is the height. So let me go ahead and do that now. So what this means is that volume is equal to pi, okay, and now I could write r squared, but r is this. So I'm going to plug that in for r. So that gives me 9 over 100 times h cubed over 3. Okay, so that's what happens when I plug in the thing that we got for r in terms of h. And let me make this a little bit nicer. Write this as 3 pi over 100 times h cubed. Okay, so now we want to find dh dt, right? So this is the part in the related rates question where we take the derivative of both sides with respect to time. So we're going to take d dt of both sides. So we want to find how the height is increasing with time. And sometimes this little pad is less than cooperative with me. And wow. Okay, so we want to take d dt of both sides. Alright, and that is no problem. So what happens when we do that? So on the left here I get dv dt, and that's how volume is changing with time, and you know they already told us that. And on the right I get the constant stays, 3 pi over 100, and now I get 3h squared times, by the chain rule, dh dt. Okay, and so now what I need to do is solve for dh dt. So let me do that. So solve for dh dt. So just move everything else over to the other side. So dh dt is equal to, okay, so I've got dv over dt, and now I'm just going to take the reciprocal of all this crap, and so that gives me 100 over 9 pi h squared. Okay, so that's what dh dt is equal to. And now I can plug in the given rate of change of volume, right? So they say water is poured into a cup at a rate of 2 cubic centimeters per second. So what this is telling me is that dv dt is 2. Alright, so I'll just go down and plug that in. So I'm almost done, you can see. So now dh dt is equal to 200 over 9 pi h squared. Okay. Alright, and so what's left? So we've got this, you know, the way height is changing would just be a number, except that we still have h in the formula here. But that's okay, because all they want to know is how fast the water level is rising when the water is 5 centimeters deep. This is telling us that we only care about dh dt when h is equal to 5. So we'll go back down to our formula and plug in 5 for h. So we do h equals 5. Alright, and how fast is the water rising when h is 5? It is 200 over 9 pi times 25. Okay, so I just plugged in 5 for h. And we could make that a little bit better because we know that 25 goes into 208 times. So this is 8 over 9 pi, and that's the answer.